rotating the graph of the function square root of x around the x-axis between the lines y is 0, x is 1 leads to the following picture. The volume of a rotation body is then given by the integral from 0 to 1 of pi times the function value squared, which is no more than the integral from 0 to 1 pi square root of x squared dx, which is pi times x squared divided by 2, which is a primitive of x between the integral 0 to 1, which gives pi over 2. In B, we use a different method. Now we have an area A which we will rotate around a vertical axis, axis minus 1. If you do that, then you get a cylindrical picture, which is denoted by the green. So we have to calculate the volume of the body of revolution of the green lines, in between the green lines. Well, the technique that may be useful here is cylindrical integration. Actually, what we're going to do is build up this green volume by cylindrical figures. Well, look at the picture left, then add some value of x. We'll make a cylinder which has a thickness of delta x. Yeah. So we'll make a cylinder here. I hope you can see it as a 3D picture now. And the green figure is actually built up from all these small cylindrical figures. Now we make a cut in this green picture and we unfold this green thing, and then the volume it takes is actually estimated by a rectangular figure with height square root of x, thickness delta x, and we estimate its length is the circumference of the basically in between the small circle area and the larger one is 2 times 1 plus x times pi. Yeah? Because we measure the difference from the figure in which we have the surface A to the axis x is minus 1. Okay, so its volume is just a product of these numbers, 2 times 1 plus x times pi times square root of x times delta x. Then we get as a volume of the body of revolution is just the integral from with x varying between 0 and 1, 2 times 1 plus x pi square root of x dx. Well, now just take out the term 2 pi and we get x to the power a half plus x to the power 3 and a half, 1.5 between the boundaries 0 and 1. Well, we may calculate the primitives of these functions, and an easy calculation shows that we end up with 2 pi times, in brackets, 2/3 plus 2/5, which makes 32/15 pi. Yeah, so again in one picture we have the area in white. It's the area A. We we rotate it on the axis -1, and we reconstruct then we get the green picture. We fill up the green solid by solids that have the shape of the red. That's the general point of cylindrical integration.